Hi, so this is Jackie Castillo, and I'm going to be doing my Chapter 4 test corrections video. Yeah. Okay, so Chapter 4 test corrections. This is my first problem. Basically, you have to integrate this, find the integral. Okay. So what you need to do is, this is like a really big kind of equation, and there's not really much you can do to integrate it, like right now. So what I did was I broke it apart. Okay, so I changed this secant to the fourth x into 2 secant squared x's. Secant squared x times secant squared x times your tan squared x. And then from here I subbed in not substitution, but I changed the secant squared x into a tan squared x plus 1, because like I tan in a second. So yeah, secant squared x times tan squared x plus 1, and you still can't really do substitution or anything for this problem. So then I multiplied in this tan squared x. So then you get tan squared x, tan to the fourth x, and then multiply that in, so tan squared x, tan. And then you still, this is in parentheses, you still are being multiplied by the secant squared x. However, what you want to do is now you can substitute, you can use substitution. So I made my u tan x, because derivative of tan x is secant squared x. Yay! Secant squared x dx. Okay, so yeah, and then you have your u. So basically what you do from here is you put in your du, which is this, and then you have u to the fourth plus u squared du. Yeah, because secant squared x, secant squared x. Okay, so from here it's pretty simple. All you have to do is take the integral, so u to the fifth over 5 plus u cubed over 3. Don't forget your vitamin C. And then you have u's in your equation. You don't want to have u's in your equation, so you have to put in your actual u, which is tan x. So 1/5 tan x to the fifth plus 1/3 tan x cubed plus c. Yep, there you go. Final answer. Okay, so for my second question, I have to rewrite this equation right here as an integral. So this question is basically rewriting the equation. Yeah, that's what it is. Okay, so what you need to do is first figure out your a, your b, your equation, and your delta x. So a, b, equation, delta x. Yeah. Okay, so first of all, you can kind of see what your equation is just like looking off of what they give you. This right here is going to be like your x, which is your function. This right here is written in the form of f of a plus k delta x. So basically what you can see from right away that 4 is going to be your a. That's your starting block for your interval. This is the full equation. This is what we need to write it as. Okay, so you have your a, we need to find our b, we'll find that later. Okay, so you can tell that your delta x is your k is most likely going to be 3 over n, and you can verify that by looking at the outside, because if it's here, it'll also be here. So yeah, that's what k is going to be. Your delta x is equal to b minus a over your n. So what we're concerned with is this b minus a. You know what your a is, and you also know that your delta x is 3 over n. So what you're going to do is set this 3 over n equal to b minus 4 over n. So you're going to have this 3, they have the same base, so you're going to have this 3 is equal to b minus 4, add 4, your b is equal to 7. So now you have your b, that's going to come in here, and what you need is your equation. You can kind of just look at it and see that you're going to have this 3 minus your x, that's what this is, so 3 minus x, and then you have it. You have to notice that this is cubed, so 3 minus x cubed, this is like your equation, and then your integral is going to be from a 4 to b 7, and then you can't forget about your dx, and yeah, that's the rewritten version. Final answer.